Okay, we're back and we're handling AP Calculus AB Content Chapter 0 Pre-Calculus Review 0.2 Functions and Graphs Part 2. So with this, we've started out with a piecewise defined function, and the minute I would see this when I was a student, I think I'd get a little bit excited, and there's one thing that led me to that, and it's this little bracket. Like, oh my goodness, it's so fancy or something's really weird happening, but let's see if we can deal with this. Now, if you notice, and what you do is you do what you do when you have a complicated problem. You take a complicated problem, you break it into several simpler problems. So you look at each part of this and you say, all right, f of x is a function that's equal to negative x when x is less than 0. So let me be clear about that. That's telling you the domain just for that part. And then the same thing is happening with x squared when x is between 0 and 1. And then the last part of it, the domain x is greater than 1 when f of x is equal to 1. So just to be clear on that, we need to pay attention to whatever that statement is, but also what the function is itself. So considering the first part, let's go to our highlighter here. And right here, when x is less than 0, we're going to pay attention to what the pink function is. When x is between 0 and 1, we're going to pay attention to what the blue function is. And then when x is greater than 1, we're going to pay attention to what the green function is there. So starting off with the pink, we're going to say, all right, in this area, we're going to be drawing our y is equal to the opposite of x function. So that's a line that has a -1 slope, and let me get out of this, -1 slope and starts at the origin. And yet, let me do it like this. Start at the origin, I've got an open circle, and we go up one and to the left one to this point. And we're just going to start by drawing our line through. And when x is less than 0, our function looks like that. For the blue part, we're going to start at the origin and we're going to draw x squared. So we're going to start at the origin. 0 squared is 0. So we're going to fill the hole. Then we're going to go to the point 1, 1, and we're including x is equal to 1 as well. I put some numbers on here. 1. And so we're going to draw the graph of x squared here. So that looks all right. So that's y is equal to x squared on that portion. And then the last portion we'll draw as green. So we're supposed to draw that as y is equal to 1. So what's going to happen here, it's when x is greater than 1. So we've got an open circle that's, of course, being filled by the blue graph, portion of the graph. And we're going to head out this way. So now I highlighted the x-axis, not a part of the function, but our function then will look like this. We'll delete. Okay, so that's what your completed graph looks like. The only thing you have to remember with piecewise functions is that each branch of the function is defined, and then after the comma, they're giving you the domain for which the graph exists. Okay, so there you go for that one, f of x. Then we have the absolute value graph, where we have the absolute value of x is equal to negative x. And it used to hit me like, negative x? Why is it negative x? Well, it's the opposite of x. So if your x values here are -1, -2, -3, that means the opposite of those x values would, of course, be positive. So with that, we're going to draw the same graph we drew above as negative x. Let me make sure my points are all. And this is an open circle at the origin. And then we're going to draw our line coming straight out. Okay, there we go. And then the second part, so we have y is equal to negative x. Then the second part we have is y is equal to x. And that would, of course, be the lower part of the function. And then that domain is when x is greater than 0. Boop. X is greater than 0. So we'll just highlight that part of the x-axis. And then our function would, of course, be in pen. Our function would look like this. Fill in the origin, because we have a domain that's greater than or equal to 0. And then I'll just try to draw it here and see if I can do a pretty good job of it. It looks like I end up at the point 3. Do I end up there? 3. here, 3, right there, and draw that in there. So we have the point 1, 1, 2, 2, and then 3, 3 there. Okay, so looks good enough. So this is the branch y is equal to x that I just drew. And remember, the highlighted x-axis is just for effect as I'm choosing my domain for each branch of the function. And there you have it, there it is. So that's the absolute value, a piecewise function. Now we'll deal with composite functions. Remember that when we say the function f of g of x, that's the way it's read. F of g of x is the composition of f with g. It's made by composing g and f in the order of g first, and then we apply the f function. So the inside function is g of x. The notation for this composition of function looks like the fog, if you will, read as f of g. Thus, the value of f of g at x, get used to this, the f composed of g on this side is equal to g on the inside, f of g of x. So the order of f and g stay the same with the notation. So g is on the inside, g is on the inside, and f is on the outside. Okay, so let's try this then. We have find a formula for f of g of x if g of x is equal to x squared and f of x is equal to x minus 7. So there are a couple ways that we could do this. We could say like this. We could say, all right, well, let's find g of 2 first. G of 2 is equal to 2 squared. Okay, 2 squared, or it's equal to 4. So then we have this notation. Then we could say it's equal to f of 4, which then we go to our function for f, which is x minus 7. So it'll just be 4 minus 7. And our answer then would be negative 3. We could handle it like that. Okay, and that would typically be how you would look at it. The second way that we could do this is that we could say, all right, what is f of g of x? So we could say f of g of x is equal to, f is that function, it's something minus 7. And you could say that we could say, all right, g of x is inputted into the function, which would be equal to x squared minus 7. So there we would have a function f of g of x. And then we would say f of g of 2, f of g of 2, then would equal, we would just put 2 squared minus 7, and that would give us the 4 minus 7, which is the same answer you'd get originally, negative 3. Okay? So that's dealing with compositions of functions. Now we'll use the compositions with a table. Using the table to the right, find g of f of 2. So the first thing you want to do is the inside first. So we want to know what f of 2 is. Oops, sorry. Okay, so f of 2, we want to go to the value of 2, and then we're applying the function to, we're applying f, so we get the answer 3. Then after we do that, we are looking then at g of 3. So then we now need to come to the 3, and then we're going to go all the way over to the g column, and then we get negative 1 for our answer. So we have g of f of 2 is equal to g of 3 is equal to negative 1 for our answer. Okay, and that's composition using a table. So folks, this is our second lesson, and I have a quick review quiz for you to do, and then you of course have your assignment in 0.2 functions and graphs. Thank you so much. Have a nice day. Alan out.